Pipe support modeling has always been one of the biggest challenges for AVEVA E3D and PDMS designers. One approach is to use the support module. However, because it often produces errors and can be difficult to manage, many designers prefer not to rely on it. A more popular and practical solution is to create pipe supports as attachments. This method is easier to manage, more reliable, and integrates seamlessly into the piping model. In this picture, you can see a custom pipe support that has been created and inserted into the model as a standard piping component. Let's begin with the standard drawing for the pipe support. As you can see, this drawing is for a shoe support designed for pipe sizes ranging from 2 inches to 10 inches. The shoe support consists of 3 main components: a horizontal base plate with a specified width and thickness, a vertical plate with a defined height and thickness, and a saddle with its own angle and thickness. All of these components share the same overall length, L. As mentioned earlier, this support is intended for pipe sizes from 2 to 10 inches. The table below provides the material specification, along with the dimensions H and L for each support size. In this tutorial, we'll use H equals 100 mm and L equals 200 mm. The horizontal base plate has a thickness of 5 mm. The vertical plate is 10 mm thick, and the saddle thickness is 5 mm. Now, let's move on to the AVEVA Catalogue. In the Master Pipe Kata database, create a new section called Support, as shown on the screen. Next, create a new category named Shoe 210. This will open the component modeling window. In the first row, rename the component for a 2-inch or 50 mm pipe. The first step is to define the component parameters. The first parameter is the nominal bore. The second is the connection type. The third is the pipe outside diameter. The remaining parameters define the dimensions of the shoe support. Enter them one by one. Height of the shoe support. Length of the shoe support. Width of the shoe support. Horizontal plate thickness. Vertical plate thickness. Saddle thickness. Next, set the G-type value to ATTA and enter the remaining parameter values for the 2-inch shoe support, exactly as shown. Now it's time to define the point sets. Create two PTCA point sets at the model origin, as illustrated. Next, we'll model the shoe support itself. We'll use two SBox primitives and one SRev primitive. Let's start with the horizontal plate. Create an SBox and enter the following parameters. X equals parameter 6, which is the width of the shoe support. Y equals parameter 5, the length of the shoe support. Z equals parameter 7, the horizontal plate thickness. Then enter the position of the plate relative to the model origin, as shown. Click Apply, and the horizontal plate will be created. Next, create another SBox for the vertical plate. Enter the following values. X equals parameter 8, the vertical plate thickness. Y equals parameter 5, the length of the shoe support. Z equals parameter 4, the height of the shoe support. Specify its position relative to the origin. Then click Apply. The vertical plate is now complete. Now let's create the saddle. Run the SRev command. Define the axes in the order shown, and set the rotation angle to 120 degrees. Next, we need to define the cross-section. Looking at the shoe support from the top, you'll see the profile shown on the screen. Enter the coordinates of points 1 through 4 one by one, using the parameter values. Click Apply, and the saddle will be generated, completing the shoe support. Finally, repeat the same process for the remaining pipe sizes. Entering the corresponding parameter values until you've completed the catalog for 2-inch through 10-inch shoe supports. Now, if we look at the hierarchy, we can see that SCOM components have been created for each pipe size. The next step is to assign them to the appropriate specification. Open Spec A1A, as shown, and select the ATTA heading. Using the Edit References window, assign the correct catalog reference to each pipe size, just as shown on the screen. Once that's done, save the specification and switch to the model module. In this example, a pipe rack and a pipeline have already been modeled. Our goal is to position the pipe 100 millimeters above the pipe rack. VARs, determine the bottom of pipe elevation using the command shown. Then subtract the pipe rack elevation to calculate the current clearance between the pipe and the rack. Next, select the elbow and use the Drag by D command. Move the pipeline downward by 250 millimeters so that the clearance between the bottom of the pipe and the top of the pipe rack becomes 100 millimeters, which matches the height of our shoe support. As you can see, the pipeline was created using Spec A1A. Now create an attachment immediately after the elbow. The custom shoe support we created earlier is now available in the specification. Place it at the desired location on top of the pipe rack. Create another attachment and position it at the next support location. Next, rename each attachment with a meaningful support tag. In the Attributes window, enter the support name in the text attribute so it will appear on the isometric drawing. Also, set MTO component to off. This prevents the support from being included in the material list while still allowing it to appear on the isometric. Finally, generate the isometric drawing. As you can see, each support is clearly displayed with its assigned name, making the drawing easy to read and identify. At the same time, the supports are excluded from the material list, exactly as intended. If you found this tutorial helpful, please consider subscribing to the channel. Your support helps us create more practical engineering tutorials and educational videos in the future.